Hello, AP Chem students, and welcome to topic 7.5, magnitude of the equilibrium constant. So today's learning objective is 7.5.a, explain the relationship between very large or very small values of K and the relative concentrations of chemical species at equilibrium. So, reaction magnitudes. So the equilibrium constant allows us to predict several things. If a reaction will occur, but not how fast. That was kinetics, okay? Whether a given set of concentrations is at equilibrium, and in which way a reaction must proceed for equilibrium to be achieved. Now, this if a reaction will occur is actually kind of relative as well, and that ties in closer to thermodynamics, which we'll get more into later in the course, okay? So to think about these things, realize a couple of factors. First of all, remember that your K is equal to your concentration of products over your concentration of reactants. And I know I'm sounding like a broken record, but it's just so important in reasoning through equilibrium that you remember that relationship. So if K is very large, then that means that your numerator is larger, which means that your reaction essentially goes to completion or lies far to the right. And so in that case, we would say way more products and not as many reactants, and that would make your K value large. On the opposite situation, if K is very small, the forward reaction only occurs to a very slight extent, which means it lies far to the left, or in other words, it favors the reactants. I'll move my face over there. So do realize, however, that kinetics also play a part in whether a reaction will occur, and sometimes limits a reaction regardless of the equilibrium expression. So there are situations in which something has a favorable K expression to proceed towards products, but the likelihood of the two species interacting with each other is super low. And so then it might be favorable in terms of equilibrium position, but it's not favorable in terms of kinetics. And by the way, that's when a catalyst might become helpful, okay? So we can also think about this in terms of a particle diagram. We're going to look at particle diagrams a little bit more in a couple of sections, but I think it's helpful to show them now. So if you have an intermediate magnitude of K, and so I don't like giving you like specific numbers because this is a spectrum and it's all relative, but kind of think in the like 10 to the negative third, 10 to the third, so 0.001-ish to 1,000s, like in that range. It's intermediate. You more or less have got the reactants and products in some relatively similar balance. When your K is very small, that means that the reactants are much more favored than your products. And so you're much less likely to go towards your products. It doesn't mean it isn't important. It just means that it doesn't happen to a great extent. And we're going to explore that a little bit more later on in the unit. If K is very large, that means that it's mostly products, and it doesn't turn back around and go back to reactants very often. But again, it is still to a great extent. I don't want to say the word often. It does happen, and it happens at the same rate as what you're making the products. It's just that when you get to that point of equilibrium, the reactants are not favored as much. And so that's what we think about with the magnitude of K. Again, I want to remind you again, we kind of talked about this before, that if your K is very, very large and you strongly favor the products, there are situations in which you can assume it goes to completion. So if you see really huge K values, like 10 to the 20, 10 to the 30, that just goes in reverse so infrequently that even if it were to turn around and make the reactants, by the time we take significant figures into account, it wouldn't make an impact. And so in those cases, you can treat a system that might initially look like it's at equilibrium as if it's actually being, you can do those calculations stoichiometrically. So just keep that in mind. Okay, so what should you be able to do with this? Well, you should recognize that systems that are essentially go to completion or barely proceed at all by examining the magnitude of the K values and let that help you make decisions about how you're going to approach the problem. And we will be looking more at the equilibrium constant and how to manipulate it in our next video, which will be 7.6, and I'll see you soon for that.